Hey y'all, welcome back. So today we are going to be practicing graphing these sinusoidal functions for sine and cosine. We're going to have a variety of different transformations going on. We'll see some with all kinds of different parameters. And we'll just take this step by step and kind of figure out, how do we graph these? What might be an efficient way to do it? A few things that we need to make sure we have on all these sketches is not only the curve itself, that's of utmost importance, but also we need to make sure that the horizontal and vertical axes are labeled with our scale and in the actual axes. But let's dive in and see what we can do here. So as we talked about in the lesson last time, all of these curves will basically look the same, with the exception being, if they're negative. So let's go through and just real quick identify what our positive sine, positive cosine, and negative cosine graphs looks like. So let's just say we have sine here. So if we have got like, let's make that a little bit smaller. That will not do. Here we go. So let's say we have, y equals just regular old sine x. So just keep this simple, we'll just say sine x. So sine x is going to start at equilibrium. It's going to go up, come back down, and do something like that. Okay? If it's negative sine x, then the whole thing will be flipped over that midline, which I'm calling equilibrium. And so instead of it going initially going up, it's going to initially go down and then do something like that. If we have a cosine graph, then it's going to start at the maximum, go all the way down to the minimum, and then come back up. And it will pass through equilibrium in between the extremes. So we'll start at a maximum, go back down, and then do something like that. And then if finally we have negative cosine, it will, instead of starting at the maximum, start at the minimum, go up, and then come back down. Okay? With our, I don't know if this is going to come out very well, but like here is my little window that I'm working with on each one of these. And I'm hand drawing these, so they're going to be a little messy, but I think it'll be okay. All right? So yeah, basically like with sine, once again, we start at the equilibrium, we hit the maximum, equilibrium, minimum, equilibrium. For negative sine, we start at equilibrium, go down to the minimum, then we hit the equilibrium again, maximum, and then, let me zoom in here. Let's just zoom in here a tad, shall we? So yeah, let's draw this a little cleaner. For cosine, we start at the maximum, we go down to equilibrium, down to the minimum, equilibrium, maximum, and for cosine, we started at minimum, equilibrium, maximum, equilibrium, and then we end off at a minimum. So what I'm trying to get across here is that all of these graphs will basically look like one of those four. Okay, so roll a dice, four-sided die, and you got a 1 in 4 shot of your graph looking right if you just randomly pick one. Let's make this look nice on here. Okay, so we'll probably zoom in as we do these, but let's go through actually how you do these. So first things first, I'm going to go through all of these just so you can kind of see that you approach it in the same way, and I'm going to work these all out sort of at the same time. Okay, and what I'm going to do is basically show you each characteristic and how it affects the graph. So let's first go through and plot all of our positive sine graphs. So like number one is a positive sine graph. So I'm going to plot these points, and then I'm going to connect them. Okay, maybe I'll zoom in to make this a little easier on myself. So yeah, I'm going to go like this, come back down, and then do something like that. Okay, and I'm going to show a little arrow to show that it continues on. This cycle is not the only cycle. So I'm going to copy and paste that exact same image to all of my positive sine ones. So let's see what else we got here. 2 is a negative sine one, so we're not going to do that. I'm scrolling down. I see 1 at 5, so I'm going to use that. No, it's the exact same graph. Let's see, 6 is a negative cosine, negative sine, positive cosine, negative sine. It looks like that's it. Those are only 2 positive sines. Let's find a negative sign, like this one. So we start at equilibrium, and since our graph is reflected over equilibrium, we're going to start by going down instead of up. So here we go. I'm going to zoom in again, but on this one, didn't like that zoom. I don't think you can see what I'm doing there. Well, there we go. Squeeze it on there. Anyway, we're going to go down. I'm going to come back up through equilibrium, pass through the maximum, and then go back to equilibrium. Oh, I really don't like how that looked. Maybe I should just do this in sections. A little tricky making this look nice, especially with a mouse. And there we go. And it does continue in both directions. Okay, so there's my negative sine graph. So I'm going to copy that on all the ones that are negative sine. So I don't have to redraw that. So cosine, negative cosine, negative cosine. Here's a negative sign, -8 sine, so I can use it there. Positive cosine, here's another negative sign. Now, you've seen a couple of these where the constant is out front. It might be worth rewriting those so that we don't get confused on what those parameters actually are. So like for instance, if I'm looking at number 6 right here, notice it says 5 minus cosine x. Well, that is equivalent to saying y equals negative cosine of x plus pi over 3. There we go. There we go. And was it positive or negative 5? I can't see. There we go. So, and then plus 5. So if you've got that constant out to the front, it might be worth taking a moment to just rewriting the equation so that it fits the same format that we've been working with. There's nothing wrong with it. It's just not in a traditional format. I think there was one other one. Yeah, this number 9, where I think it's worth rewriting this one as well. Y equals negative sine x minus 1. So it's not like you have to do that, but I think it can be helpful. All right, now let's throw down some cosine graphs here. So cosine, the positive cosine, is going to start at a maximum. So we start at a maximum right here, go down to equilibrium, the minimum, equilibrium, maximum. And so the curve was going to do something like this. You want to make sure it looks nice and curvy, okay? We don't want any straight lines here. This is not linear at all. So doing the best I can with this mouse, but basically it's going to keep going like this, and then it is going to kind of curve back down. Okay, so there's my cosine. All right, kind of looked like what I had sketched up here. And I'm going to copy and paste that in all my cosines. So look at this. I'm going to have all my curves down before I even really get started. So these two down here are both positive cosine graphs. So I can use what I've got here, use what I've got here. And then over here with the negative cosine graphs, those are going to be flipped. So instead of starting out at a maximum like I did on number 3, I'm going to start at a minimum and go up and down like that. I want to make sure you can see it. I guess that's as far as I can zoom in the way this whole thing's configured. Okay, so we've got a point at the minimum, at equilibrium, at the maximum, equilibrium, minimum. So it's just that positive cosine curve, but simply flipped over. And it will eventually curve back up, on the past this little grid. If I can make this look, what is going on with this mouse? I don't know why it's lagging so bad. There we go. Let's go ahead and copy and paste it to, I think it was just that one last one, and then we got all of them. Yeah, just this one. So I'm gonna go ahead and highlight this, copy and paste it, and look at that. Okay, so far, now we've got all 10 graphs totally done. So there's, you can take a screen grab if you want. There's 1 through 4. Here is 5 through 8, and then 9 and 10. So all the curves are done. Now what we're going to do is go through each of the 4 characteristics and use those to help us plot the graph. So let's start with the vertical shift. So on each one of these, I'm going to label what the vertical shift is. So I'm going to make like a little, not a cheat sheet, but just a little guide here where I'm gonna figure out what that vertical shift here is. Now, since I'm not adding anything up here, it's just gonna be 0. So here my vertical shift is 0. So I'm gonna label my equilibrium with a 0. Okay? And what I'm gonna do is I'm just gonna find all the vertical shifts. Okay? So vertical shift on number 2, I'm not adding anything here, so that's just gonna be 0 again. For number 3, my vertical shift is actually 1 here. Notice I'm adding 1. So what that does is instead of my equilibrium being 0 like number 1 and number 2, my equilibrium here is 1. So I'm going to label that with a 1. For number 4, my vertical shift is -1. Okay, you notice that we're subtracting 1 right here. So that'd be -1. So for my labeling, I'm going to put a -1 right there. For number 5, my vertical shift is going to be 3. Oh, I missed this one. When I was going back earlier and trying to rewrite some of these that had the constant first for whatever reason, I missed this one. So I caught it on number 6, and what was the other one? Number 9. But I did not catch this one. So let's rewrite it just to make it a little easier to read. So we got 2 sine of 3 pi x. Ooh, that one's gonna be a doozy. Okay, plus 3. All right, yeah, that'll be interesting once we calculate the period on that one. Okay, so yeah, the vertical shift on this one is 3. So I'm gonna label my equilibrium with a 3. For number 6. What's my vertical shift on number 6? Vertical, oh no, that is not what I wanted. The vertical shift here is going to be 5. Okay. So I'll label that equilibrium with a 5. And then let's keep going. Let's keep going. Number 7, vertical shift is a -3. Let's just knock the rest of these 4 out, and then we'll go back and label it on the graph. Here, vertical shift is going to be 10. For number 9, the vertical shift is -1. Hopefully, you're seeing where I'm coming up with these numbers. It's just the number you're adding on each one of these. And finally, the vertical shift here is going to be 2. So let's go back and label these. Number 7, this should be -3. This should be 10. This should be -1, and this one's going to be 2. All right, so that takes care of the vertical shift. The next characteristic we got to find is the amplitude. So let's compute the amplitude. It's going to be the absolute value of the a value, or the coefficient to the function. Now, if you don't see an a value, like in this case, you don't see anything, there is an implied 1. So here the amplitude is 1. So let's just go through and calculate the amplitude for all these, and then I'll show you how to use that. In this case, the amplitude is also 1. So the amplitude is calculated by taking the absolute value of this coefficient. Okay, the absolute value of -1 is 1. Basically, you're going to take the number and change it to be positive. Amplitude here, looks like it's also 1. All right, come on, let's get something else. Number 4, amplitude is 1. All right, I'm getting kind of bored here. Let's switch it up a little bit. Come on now, who wrote these problems? This is too easy. Number 5. Okay, here we go. So the amplitude here is going to be 2, because you can see this 2 right there. So the amplitude here will be 2. Finally, something a little different. Over here, number 6, the amplitude is going to be 1 again. Right? The absolute value of -1 is 1. For number 7, the amplitude is going to be 8. For 8, the amplitude is going to be 14. Oh, I'm liking how big those numbers are. That's something different. Number 9, the amplitude's 1. And for 10, the amplitude is 1/2. Oh, what the? Come on now. Yeah, it's just 1/2. Or 0.5, however you want to think about it. In fact, let's go with the 0.5. I kind of like that. All right, so the way you're going to use the amplitude to actually label the graph is the amplitude is the distance from equilibrium to the extremes. Okay, so in other words, the distance between here and up here is the amplitude. So the way that you use that to label this is you are going to add or subtract whatever the amplitude is to find the values of the maximum and minimum. So 0 plus or minus 1 would be 1 and negative 1. Over here, 0 plus or minus 1, same thing, 1, negative 1. For number 3, 1 plus or minus 1 would be, 1 plus 1 is 2, but 1 minus 1 is 0. So you can see that the x-axis is going to be down here rather than at equilibrium, like the previous problems. Number 4, amplitude is 1, so negative 1 plus 1 is 0. Negative 1 minus 1 is negative 2. For number 5, the amplitude is 2. So 3 plus 2 is 5, and 3 minus 2 is 1. So the x-axis down here, when we get to it, is going to be actually below this graph. We can see that because 0 is like going to be a little bit below 1. For this one, the amplitude is 1, so that's going to put the maximum at 6 and the minimum at 4. This one, the x-axis is way down here. Yeah, I'm not sure how we're going to show that without running into the next graph, but we'll do the best we can when we get there. For number 7, let's see, the amplitude is 8, so negative 3 plus 8 would be 5, and negative 3 minus 8 would be negative 11. So pretty big vertical stretch there, right? Factor of 8. This one's even bigger, though. Vertical stretch is a factor of 14, so 10 plus 14 is going to be 24, and 10 minus 14 is going to be negative 4. For number 9, the amplitude's 1, so we're going to add 1, subtract 1. We've already done one like that with the vertical shift to negative 1, amplitude 1. And then if the amplitude is a half, we're going to do 2 plus a half is 2.5, and then 2 minus a half would be 1.5. Or you could say like 5 halves, 3 halves, same thing. Okay, so that's 2 out of the 4 things. The next thing we're going to do is calculate the phase shift and period so that we can label the horizontal axis. To calculate the phase shift, and by the way, the phase shift is where this is going to start. Oh my goodness. I just looked at my screen. You can't see what I'm writing over here. Wow. Okay, let me zoom out. Let's take a minute and go over. I don't think, I could be wrong, but I don't think you're going to see any of this on what I did previously. So let's just kind of slow down here, pump the brakes here and go over. Vertical shift is 0, amplitude is 1. Down here, amplitude is 1. I'm sorry, the vertical shift is 1, amplitude is 1. Here the vertical shift is 3, the amplitude is 2. So 2 is the distance between 3 and 5 and 3 and 1. Down here the vertical shift was negative 3, and the amplitude was 8. So 8 up and 8 down. Finally, number 9, the vertical shift was negative 1, and the amplitude is 1. So up 1, down 1. Sorry about that, y'all. Hopefully you saw enough of, especially these ones over here, to kind of get the feel for how to find that. But let's cut our losses and move on. Let's go over the phase shift, okay? So the phase shift is where your cycle begins. It'll be right here. And the way you calculate that is it's C divided by B, okay? So in this case, the C is 0 because if you'll notice, we're not actually adding anything here. Okay, this is, if there was like a plus something, we would have a phase shift. But since it's plus 0, we're not adding anything to our x term. The C is 0. 0 divided by 2 pi. 2 pi would just be 0. So the phase shift is 0 here. Okay, and I'll show you this one, but from here on out, we'll just calculate all the phase shifts and then go back and label. Okay, so the phase shift is 0. For number 2, the phase shift is going to be C over B, so that's going to be 2 pi. I'm going to have to grab a pi here. I'm getting hungry. Okay, anyway, where's pi? Come on, give me that pi. There we go. Now I got an extra pi over here. All right, anyway, seriously, okay, hold up. There we had, I just had to do a little copy-paste action here. Okay, so anyway, 2 pi over 3. Okay, so that's going to be what we label this with. We'll come back to that. For number 3, C over B is going to be pi divided by 1/2. Okay, so I don't really like that. Dividing by half is the same as multiplying by 2. So the phase shift is going to be 2 pi. Over with number 4, phase shift is going to be C divided by B. Again, I'm going to keep saying that. So we have pi over 2 divided by pi over 3. Okay, so I'm going to let you figure out the arithmetic here, but basically when you divide fractions, it's the same as multiplying by the reciprocal. So it'd be like pi over 2 times 3 over pi, which would reduce to just 3/2. Actually, you know what? I just caught something. It should actually be negative, because this C value is actually negative pi over 2, and the same thing's going to happen over here. I'm sorry, y'all. Slipping. I gotta pay closer attention here. So this is going to be negative 2 pi over here. My bad. Basically, it's going to shift it to the left rather than shifting it to the right. This one up here should be good because we get the minus. Okay, so let's keep moving on. Let's not dwell. We dwell on our mistakes. It's going to drive us crazy. But it's okay. Hopefully you guys see, like, as we're going through these videos, that I make mistakes too. I overlook stuff, but I'm not going to whine or complain about it. It happens. I'm just going to go back and fix it and move on with life. All right, so anyway, number 5, phase shift. We're not adding anything in here, so luckily we get an easy one. The phase shift here is just 0. For number 6, the phase shift, C over B. Now we do have a C value here. I'm not going to let it give me this time. The phase shift is going to be negative pi over 3. Divided by 1 is just going to stay negative pi over 3. So this is C, and then C divided by 1 is just going to be C again. For number 7, the phase shift is going to equal, let's see here. So that'd be negative pi over 4. For number 8, the phase shift, we're not adding anything in here again, so the phase shift is just 0. For number 9, the phase shift is 0 again. We're not adding anything in those parentheses or subtracting. The phase shift for number 10 is going to be positive pi over 4. Okay, so we got all the phase shifts. And so the way we're going to use that to help us label our graph is it's going to be where the cycle starts, like we did here. So it's going to be whatever that number is. So here's 2 pi over 3 right here. This one's going to be at negative 2 pi. I think that's the first one we have a shift to the left. Here we've got negative 3/2, no pi. Those pi's are going to cancel out. Number 5. Phase shift is 0, simple enough. Here, the phase shift is negative pi over 3. Number 7, the phase shift is negative pi over 4. For number 8, the phase shift is 0. For number 9, the phase shift is 0. For number 10, the phase shift is pi over 4. All right, so we're almost done. We really just have 2 things left for these graphs. The first thing is we are going to figure out what the period is so that we know where this window ends. And then the last thing to do is going to be to actually plot the x and y axes on there. So we'll just do like, a horizontal vertical line and show where the x and y axes are supposed to be. Okay, so the way we calculate the period is we do 2 pi divided by b. So let's calculate that. So this one is going to be 2 pi divided by b, which in this case is 2 pi. So anytime you divide something by itself, you just get 1. Okay? So what we do is we add the period to the phase shift to figure out where this window ends. So 0 plus 1 is just 1. And this one's complete. So let's go ahead and label the x and y axis here. We might as well, just so that way we can be done with this one. The x-axis will be here wherever 0 is, and the y-axis will be here wherever 0 is. So really you're looking for those zeros. So I'm going to label this with X and Y, and then that one is totally done. Okay. The period on number 2 is going to be 2 pi, always start with 2 pi, divided by the b value. So 2 pi divided by 3. Ooh. Okay. So what we need to do is we need to add 2 pi over 3 to this. So that's actually not too bad. 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. Why does it keep changing back to black there? There we go. 4 pi over 3. So our x-axis is going to be where 0 is, but our y-axis is going to be where, you know, the x is 0. If this is 2, this is 4, it's going to be like way out over here. I hate to put it this far over, and it's not really that important that you get it like exactly perfectly, you know, to scale, but do show me that it is kind of like outside over here. For number 3, our period is going to be 2 pi, always 2 pi divided by 2 pi divided by b. In this case, b is 1/2, right? So dividing by a half is the same thing as multiplying by 2. So that would, 2 pi times 2 would be 4 pi. Let's move this over here. Oh, there we go. Okay. So, so negative 2 pi plus 4 pi is going to be 2 pi. So that tells me that the x-axis is down here. Oops. There we go. X-axis is down here, and the y-axis is right down the middle. Look at that. Well, that's the first one we've seen where that happens. What just happened there? I'm not sure exactly what happened there. Okay, so here's my x, here's my y. Yeah. Oh, that's kind of weird. But yeah, there we go. Okay, so number 4. Our period is going to be 2 pi divided by b. I'm going to keep saying that until you got it, you know, implanted in your brain. 2 pi divided by pi over 3. Again, we have this dividing by fractions business, which means we're going to multiply by the reciprocal. When that happens, the pi's will cancel out, and we'll multiply 2 times 3 is 6. Okay, so negative 1.5 plus 6, you know, might be easier, I'm thinking, to think of these as decimals. So I'm going to change this to negative 1.5. And then that way just be a little bit easier for me to add here. So plus 6 is going to be 4.5 is where this is going to end. So my x-axis is up here. My y-axis is going to be, actually the way this splits up, you know, this is 6, so this is 3. So it's going to be positive 1.5. It's going to be exactly right here. Yep. That looks pretty good. Okay, number 5. So number 5, again, the period is 2 pi divided by b. So here we have 2 pi divided by 3 pi. So the pi's cancel out, and we just get 2/3. So 0 plus 2/3 is simple enough. It's just 2/3. So my x-axis, which is going to be a little bit below here, because look at this, 5, 3, 1, and then 0 would be right below that. And then my y-axis will be right along this, you know, left part of the window. For number 6, let's calculate that period. So we've got 2 pi divided by b, and we just have a b of 1 here. So it's just going to be 2 pi. So what we have to do, though, is add 2 pi to pi over 3. Negative pi over 3, rather. So let's see how that's going to work. I'm going to type it out here. So we've got negative pi over 3 plus 2 pi. And whatever this ends up equaling, that is going to be the endpoint here. Well, 2 pi is equivalent to 6 pi over 3. And we'll need to write it like that to get a common denominator. And then now we can combine. Negative 1 plus 6 is 5. So this will be 5 pi over 3. So now that we've computed it, I'm just going to go ahead and handwrite it here so I can stay consistent with how I've been labeling everything. 5 pi over 3. Okay, my x-axis, ooh, this is the one I was talking about before. Oh, gosh. You know, I don't want to, like, cross into this territory of number 8. So even though it will definitely be lower than this, you know, this is about as low as I feel comfortable going. So, let me pause this. All right, sorry, technical difficulty there. So anyway, yeah, our x-axis is going to be way below here. So just do the best you can, you know, make it obvious that you know that it's supposed to be down below. And then our y-axis is going to be right about here. Okay. Now one way to kind of figure out more precisely where that's going to be is just to kind of work your way in half. Instead of adding 2 pi, just add a single pi, which would put you right here at 2 pi over 3. You don't need to include this, but like if you're just trying to figure out where that axis is supposed to go, and halfway between negative pi over 3 and 2, like if I were to average these to figure out where this is at pi over 6. And so then you can say, okay, well, it's going to be in between those. So you can kind of figure it out that way. You know, just do your best to estimate where that's supposed to go. 4 more. Almost done. So number 7, our period, once again, is 2 pi divided by b. So 2 pi divided by 4 is going to reduce to just pi over 2. Okay. So we're going to add pi over 2 plus negative pi over 4. It's like adding 1/2 to negative 1/4, right? You end up with positive 1/4. Yeah, so this is going to be, you know, negative pi over 4 plus pi over 2 is going to be positive pi over 4. And if you're not convinced, you know, I encourage you to try to do that arithmetic on your own. You know, just practicing adding fractions is always a good thing to do. Whoa, I don't want to move all that stuff. Why'd you grab all that? No, I just want this. All right, well, that will have to, oh, there we go. I can just do that. Cool. I didn't know I could do that. All right, anyway. So you can see that because of the symmetry here, we can tell where that y-axis is supposed to go. Now the x-axis, you know, this is negative 3 and 5. 0 is going to be, you know, should be a little closer to negative 3. So if I'm going to estimate where this x-axis goes, I'm going to put it right about here. Okay, where 0 is. And then for the y-axis, that one's clearly going to be right here. Right? It's halfway between negative pi over 4, positive pi over 4. For number 10, I'm sorry, number 8, getting ahead of myself. I hope you guys like how we're kind of solving all these at the same time. You know, I'm just taking one little piece and knocking out every single graph with that piece. You don't have to do it that way. You can just do one graph at a time. But I just think it's easier to sort of stay focused and just do one thing at a time if you can. So 2 pi divided by 1 is just going to be 2 pi. So 0 plus 2 pi is 2 pi. Now, you know, some of these are going to be a little bit easier than others. When you have to start adding fractions, it can get a little tricky. But especially when that phase shift is 0, it makes finding the end of that window very easy. My x-axis is going to be somewhere in here, closer to the negative 4 than the 10. But I'm not going to be too worried about it if it's perfect. So there's the x. Then the y-axis will be right here. Here's my y. Just didn't really want to encroach on this number with this low x. Okay, I won't go back to that. Yeah, there we go, number 8. Okay, so let's do number 9. We're almost done. The period here is going to be 2 pi divided by b. Probably sick of me saying that by now. So 2 pi divided by 1 is just 2 pi, and 0 plus 2 pi is 2 pi. The x-axis is going to be right here, and the y-axis is going to be right here. And our last one, number 10. the period is, why did it switch on me? That's weird. Okay, 2 pi divided by b. Our b is 1, so it's just 2 pi. And we've got pi over 4 plus 2 pi. So 2 pi, to add that, we need a common denominator, which would be 4. So 2 pi, you could think of it as like 8 pi over 4. So 8 pi over 4 plus 1 pi over 4 is going to be 9 pi over 4. So our axes are going to be a little off the grid on this one too. Okay, my x-axis is going to be, oh, whoa, what happened to that 4? Let's just clean that up just a smidge. So my x-axis will be below this 1.5, so it's going to be somewhere down here. There we go. So there's my x. And then my y-axis is going to be before, both of these are going to be off the grid. So if this is pi over 4, then my y-axis is going to be somewhere over here. All right, so that's a lot of practice graphing these, and some of these are not easy. This is a pretty good selection with some easy, some medium, some hard ones. I'll focus probably more on the easy to medium level ones, like, as it pertains to the test. But if you know what you're doing, I think the hardest thing to do, besides like keeping track of what everything means, is just the adding fractions. Always comes back to adding fractions. Make sure you're good with that. You don't want to mess up this horizontal scaling because you couldn't add a fraction. But that's it for today. Hope you all enjoyed doing this practice, and y'all have a great day. I'll see you next time.